Hello all, welcome to this online recording sessions in data science. So in this session, we are going to see one of the deep learning concept, that is RNN. RNN stands for Recurrent Neural Network. So we have seen that why the application of RNN. So when can the RNN can be used means it can be used when our data set is in the form of time series or in text format. Then we can apply RNN technique. Okay. Yeah. See, before that, I would like to discuss the our brain. See, our brain has these parts, right? Front lobe, temporal lobe, brainstem, cerebellum, octal lobe, parietal lobe. So all this, right? So in this, you tell there is a permanent storage and temporary storage in our brain also, right? Some things we need to store temporarily, and some things we need to store permanently. Like if I ask who is your father or who is your relatives, then you are able to recognize and tell, because that some data like that is stored in permanently in your brain. But data like so at 12 o'clock in the evening or day before yesterday, so what you have done means we can't remember. Like we can't remember at that point, at that second, what our brain has done, what activity we have done, we can't remember and we can't able to tell, right? So that's what I would like to say. Our brain will not remember too many things. It will remember only the main things, and it gets stored in the permanent. Okay. And whenever it is needed, it will process our data and respond accordingly from the storage of our brain, right? So in the same way, this concept is applied into our deep learning concept also. Okay. So let us see in this RNN how this the scenario which I have discussed will be applicable into this RNN concept. Yeah, RNN. So what is RNN? So RNN is nothing but recurrent in nature. Okay. And it performs same function for every input data. That means if I am performing one action and extracting one output, and that output will be depend upon the present input, as well as the present output will depend on present output will depends on present input. That means what I am telling now, and past output, what it has been stored. Okay, so it will compare all these two things, and it will answer the present output. It will extract the present output. So this is what happens in recurrent neural network. Okay, so we need to remember the present output also, sorry, past output also, and process input also, and then using these two inputs we need to process the present output. Okay, using these two conditions. Okay, so to learn this, we have one beautiful blog and good blog that is called Cola blog. Okay, Cola blog, let me open that blog and share from insights from that. So all this got existence from that blog only. Okay, so if you go to Google and type Cola blog LSTM, okay, then you will get a blog. Okay, then you'll get a blog, this one. So you can open this one. Okay, so everything, the RNN concept, how it got existence and how it got extended and all, it is described in that blog. Okay, so now let us see. So let us see this blog. Okay, so this blog, okay, this, it is published in 2015. Okay, okay, so now let me take some examples, some real life examples to take into the recurrent neural network process, how it will happen. Okay, so now you tell me. So most of you watch IPL, right? So in if I ask you in this IPL tournament 2025, so what is the status of the matches? Means how do you answer? So you do answer like yesterday, so and so teams fought with each other, and this team won has with this many runs or this many wickets, and these are the batsmen and bowlers who had scored, and this is the player of the match, and you'll be describing everything, right? And if and in the same case, if I ask you in 2010 or 2012 IPL, so what you will tell? Will you tell the same details with all the same details? But even though if I tell all the details will be necessary at the present scenario, no, right? No, we can just tell who is the winner with how many runs, who is the player of the match. That means the brief, the main key points you can take into consideration if you are talking about the past data. Okay, if you're talking about the past data, you need to consider only the key points rather the full input process. Okay, so that is what here it is shown here. Okay, so if you look into this, okay, recurrent neural networks address this issue. They are the networks with the loops in them allowing information to persist. Okay, so what is this issue? That means processing the output, how it is getting processed. So let us see. Yeah, so this is the general representation of RNN. If you look into this, so you see this is the input and this is the output, and this is our neural network. Okay, so you tell one input, one output, and one neural network. So with this we are able to process the data. Okay, process the data. But you see, if you see here what is happening, it is in the form of a loop. If you ask me, okay, that means this process is repeated. Okay, if I unfold this, how do I get this? If I unfold this repetitive process and see internally how my RNN internally looks, yeah, it looks like this. So it is the series connection of this neural network, input and output. So you can see different inputs, different outputs, and different neural networks. Okay, so all these are connected, so and so on. It is connected like this. So all together, if I, yeah, this I am getting if I'm unfolding it. If I fold it, I'll get this one. Okay, okay. So this neural network concept is mainly applicable to some of the real life scenarios like speech recognition, language modeling, image captioning, and model translation. Okay, so generally in machine translation, time series data like stock market prediction, and wherever it is the sequence of inputs are involved, like means the present input will be depend upon the past outputs. In the stock market also you will see present stocks value will depend upon the past values also. Okay, so like that neural network will perform depending upon the past output and present inputs. Okay, so let us take some examples and discuss this in detail also. So let us see how it will be. See, yeah, so now you see, if you look into this sentence, if you look into this object, the clouds are in the sky. So if I want to predict this word, you just read this sentence except the last one, the clouds are in the right. So what you could predict the next word, where the clouds will be there in the sky, right? So the sky will be the appropriate word here. Okay, the appropriate predicted word in this sentence, the last word will be the sky. This is a predicted word in this whole sentence. Okay, so this is the predicted one, and this will be the appropriate word. So if you consider remaining words, it won't fit into this sentence. Okay, similarly you take the one more. So similarly to this, you take one more scenario where, yeah, you take this sentence, I grew up in France, and I eat more, sorry, I follow this routine schedule, and I do some activities like this, and imagine there is some text like this. Okay, so I grew up in France, and there is some text continuing like this, and it will be ending with I speak fluent. Okay, I speak fluent and some word, imagine. Okay, so now you try to predict this last word in this bunch of text. You try to predict this, which word will suit. Okay, which word you will suit. Should I insert sky also here? So in previous case, previous sentence we have seen sky is the only word that can fit in that sentence. If I use another sentence, it looks irrelevant or unmeaningful. Okay, so similarly, if I read this entire text, okay, so which word will fit here? I speak fluently means generally it should be an some language speaking means, and that language should be in related to the our paragraph, entire paragraph. So in my paragraph I have mentioned I grew up in France, so then you can expect here French, right? Okay, so that means our predicted output is depending upon the entire sequence of words. Okay, sequence of words. So this sequence of words, how do this RNN model will take this challenge and try to predict it? Okay, so there are many collisions also happening, there are many ambiguities also. Ambiguity means same sentences having different meaning, or same words meaning different meaning. Like suppose rose. What do you mean by this? Okay, I mean, is it a flower? Is it a flower? Or is it a name of a person? We have seen Titanic movie, right? In Titanic movie, what is the name of one character? Rose, right? Jack and Rose. You see, the heroine name is Rose. So is that Rose? So Rose means here name of the person or flower. It is an ambiguity here. So with this word, I am getting an ambiguity here. Similarly, buffalo. Buffalo. Whenever I heard this word, generally it is an animal, but few people say it is as a place in US. Okay, so now you tell me how my models. So how my model should understand situations like this. Okay, the situations like this are called ambiguity. So this problem is called ambiguity with the words. Similarly, I flew I flew into I flew into the sky, or consider some sentence like this. So those sentence mean different ways in different way. Okay, depending upon the situation, that meaning may differ. Whether I really flew into the sky, whether I have taken a plane and flew into the sky. Okay, so all these situations will arise with the sentence cases also, and this situation is called sentence ambiguity. So ambiguity problems will arise. Okay, so all this ambiguity problem and predicting of next word, how our RNN model, RNN recurrent neural network will handle. So let us see. So how this internally function. Okay, so how this internally will function. Yeah, you could see the if I unfold this, if I unfold this simple recurrent neural networks, it is enclosed with loops. If I remove the loops, how it will look means it is looking like this. It looks like this. You can see here also. If I unfold, this is equal to this. Okay, so it is like this, right? It is so on. Okay, so now you tell me. So this is the RNN, right? So what is the problem with RNN? So handling the sequence of text. Okay, sequence of text. So is that possible with RNN? Then yes, I can say with a special type of RNN. That special type of RNN is called LSTM. So it is long short term memory networks. Okay, so what does it will do? Means it will not remember the entire sequence of words. So here also, if you ask me, I did not remember I did not know the entire text here to predict this word. Yes or no? So I can need just this important sentence or important starting sentence to predict this word. Yes or no? Yes, right? In the similar way, our RNN models also need not remember each and everything. Like I have mentioned in IPL. So if I ask this particular in this particular day means I can remember things. If I ask past data means do I need them the past data full-fledgedly? No, right? I did not need the past data entirely. So I can just take the highlight of the past data. So that means the key points that are there in the past data and try to store them and use it for predicting the next kind of outputs. Okay. So in the similar way, my LSTMs are special type of RNNs. LSTMs are special type of RNNs. Okay. LSTMs are special type of RNNs. LSTM are special type of RNNs. So it is also an RNN model only, but is a special type of RNN. Okay. GRU is also that we are going to see. GRU is also one of the special type of RNN. Okay. That we also see. Okay. So if you want to know about LSTM, you can refer this link. Okay. Now let us see how our LSTM looks. Okay. So in LSTM, what we have, the simple structure looks like this. Okay. Instead of having single neural network layer, there are 4. Okay. There are 4 here in LSTM. There are 4 parts here interacting in a very special way. So in RNN, we see CNN, input and output, right? And this is repeated in a for loop. Okay. So but in LSTM, in special type of this RNN, so you could see 4 parts. So what are these 4 parts and how these the 4 parts, let us see one by one. Okay. RNN type has 4 parts, right? Yeah. See. Now if you see, you get this one. Yeah. So this is my repeating module in LSTM contains 4 interacting layers. So what are those layers also we will see. So one is forget gate, one is input gate, so other one is output gate. So that we will see in the further section. So before that, I would like to discuss this important things also. Yellow color means here you could see in the block diagram. So all those things, right? So yellow color ones, this one. So cross means multiplication. So plus means addition. So and what are those yellow color rectangular boxes means those are neural network layers. Okay. And this is point wise operation that is happening. So that the point of wise operation that is happening here is addition. And the point wise operation that is happening here is multiplication. So and the neural network layer that is consisting here is sigmoid function. Here also sigmoid function, tan h function and sigmoid function. So here also tan h function, but this is operation, point-wise operation. And you can see if the arrows are combining together, then we can say concatenate. If they are diverging each other, then we can say copy. Okay. So we can see this is the input and this is the previous output and this is the next output, and we are trying to predict with this present input and past output. We are trying to predict the output. Okay. So now let us see. Okay. So this is multiplication, this is addition, and we are getting output. So this one is what? This yellow color means neural network, right? And it consisting of sigmoid. Okay. And this LSTM, as I mentioned, 4 parts, right? 4 parts. There are 4 interacting. Instead of having a single neural network, there are 4 neural networks that are interacting with each other. And you could see here 3 of these gates. 3 gates are there. Okay. So the first gate, the very first gate is what? The very first gate is what? Forget gate. So how the forget gate looks? So this is my entire diagram of LSTM. Before this, I have one more block also, past output, and this is my present output. Like this I will have. Okay. So, but you see, this is my forget gate. So in this forget gate, what is happening? What we need to do? So the out of all the information, what information I need to forget it? So that is decided by this neural network. Okay. This neural network which is having with sigmoid function, this will decide out of all the past data that I will be there, what is the data that I need to forget. So that is decided by this sigmoid neural network. Okay. That's why this is called the forget gate layer. So and the next layer will be somewhat. Okay. And the next layer will be this one. So what is this one? What is this one called? Input gate layer. Okay. So this is called input gate layer. So how it will look? It looks like this. Okay. So this is sigmoid function, next is sigmoid function, and this tan h function, together it is called as input gate layer. Okay. Input gate layer. Then what does this sigmoid function will do? Okay. And then what does this tan h function will do? So this sigmoid function will, what does it will do? Will decide what new information. Okay. So the previous sigmoid function will tell us what information need to be forgotten, what information need to be deleted. But this sigmoid function in the input gate layer, what it will do? Okay. What it will do? So it will decide what new information we are going to store in the cell state. So that is decided by this sigmoid function. Okay. So then this tan h function will decide what vector space I need to do. So how much vector space I need to allot for the storing of the present. Okay. Present information, for new information. Okay. That is decided by the tan h. So this entire together, which is highlighted here, this is called as input gate layer. So we have seen 2 gates so far. So one is forget gate, and the second one now which we are seeing is input gate layer. Okay. Layer. So and the next one, I have seen 3 gates, right? So the next one, what it is? Yeah. Before that, let us see. So how it is getting processed. Okay. So the vector space and the present input and everything are getting multiplied here. So everything are getting multiplied here. Okay. That's why it is operation is there. So that multiplied output is added here. So added to what? So added to this. So here what I am getting? So here I am getting the past data which is filtered by this sigmoid function. It is sent to here. And here what I am sending here? Past input. Okay. Past input and the filtered past output. Both are multiplying getting here. Okay. So I am taking past t minus 1 means past output. So past input. So past input and the filtered okay, the filtered past output. So I'm both multiplying it, and here I am adding new vectors. So new input both are getting added here, and I'm getting output here. So this can be represented in mathematical form also. You can understand by that also. Okay. So we have finished two gates of understanding, right? Forget gate and input gate. Okay. So next we are seeing a run a sigmoid. Okay. So that is all described here. So we will be getting -1 and -1 value. Okay. So now again let us see the last layer what we had. Okay. Okay. So next here what happens in the next layer, the output gate. So in the output gate what happens? In the output gate first we run a sigmoid layer. So this part is over. It is transparent. This part is over. Okay. Input gate, and this is forget gate, and this is output gate. Okay. What I'm talking now. Okay. So in this output gate, what are the things that you are able to observe? So I'm going to observe one sigmoid function. So what this sigmoid function is doing? It decides what parts of the cell state we are going to output. Okay. So now input is over. In the output state, what output I need to show to the user, that is decided by this sigmoid function. Then we put this cell state through tanh function. I said tanh function is used to create vector space for storing the output values. So previous tanh function is used to store input vectors. Okay. So all those the tanh, the vector space and the output that our model is trying to show to the user, that is getting multiplied here. Okay. So all that together it is sent to h of t. Okay. And that will be in the range of -1 to 1. So these are the three gates that you can understand in the LSTM. Okay. Input gate, forget gate, and output gate. I hope you understood these three gates. This is the third gate, output gate. Okay. So now we see how it happens, right? So if it is not, again it will be repeating. Again it will be repeating with the another LSTM block. So like that it will be repeating. So now what we can conclude from this block, we talked about RNN, right? We talked about RNN, how that RNN will take the sequence of inputs and process the output, right? And from that RNN, how we have designed the special type of RNN with LSTM by changing the adding 4 layers and 3 gates. Okay. So that we have seen, right? So we can generate like this many RNN types. LSTM is one of the RNN type. So like that, you can change we can remove or change these 3 gates as well as the 4 channels that are described just now. Okay. So you can change these parameters and you can generate another type of RNNs. So that is what only it is described here. So one popular LSTM variant introduced by Jers and Schindler was it is introduced by LSTM was introduced by these people. Okay. Normal LSTM. So next it will talk about the remaining ones. So next you see another variation is used to couple the forget and input gate. If I couple forget gate and input gate, then I am getting the another RNN type. Okay. So you could see if I coupled what happens. So this is the couple symbol I have used. Okay. Now I can generate another type of RNN. So you can name this type of RNN. There is a name for this this combinations of inputs and channels they have specified, and they have given another name also. Okay. So you can see the peepholes to all the gates. So what are these peepholes, how they are added, and how these combinations and what name they have given if they combine these two gates. Also you can see it here. You can read it here. Okay. Next you will see the slightly more dramatic variation of the LSTM. Okay. So you understood the LSTM, right? So now if I make some little change to that LSTM, okay, little change to that LSTM, you get GRU. GRU means gated recurrent unit, okay, GRU, okay. It is introduced by, you could see the author names and you could see the link for that also. So now in this special type of GRU, this special type of RNN, what combinations I have used? I have combined the forget and input gate, okay, forget gate and input gate into a single one, okay. I have combined this gate. In LSTM I get forget, input and output, 3 gates I have, right? But in GRU what I have done, I have modified that LSTM RNN, okay, and it happened in 2014, okay, it happened in 2014 after LSTM GRU came, okay. So instead of forget and input gate, I have combined together. You could see the diagram here, okay. So how it looks if I combine forget gate and input gate, how it looks. Now I will be having only one input and one output, okay. That is in the case of GRU, okay. So you can look into this. So you can look into this sigmoid functions, what it does, okay. What does tanh function, as I mentioned, creates vector spaces. So sigmoid function will filter out the data. If it is the sigmoid function is used in input, it filters out input data. If sigmoid function is used in output, it filters out output data. That means the required data is only extracted, okay. So in this way, some data we are forgetting it, okay, and some data that is very very important, that we are trying to store it and trying to use it for predicting the future outputs, okay. In this way RNNs are getting worked, okay. Okay, so there are a lot of others like this depth, okay, gated RNNs. So there are many authors that have come forward and tried the combination and tried to bring the better possible RNN model, okay. So I like to show one video also, so how that internally it is happening, how the textures are combining together, and you could see that also in this video. So let me show that also. So this is how the general RNN architecture looks, and if I unfold, I have shown how it looks like in the blog also. And there are many types of RNNs, okay. So one to many, okay. So there are many types. If I want to talk me about on this, I can say one to one RNN, one to many RNN, many to one, and many to many. So these all are the different types of RNN. You could see the examples, okay. So for one to many, you could example. So dog is the one input, okay. Dog is the one input, and this blue color and white color strips are the many, right? So you can consider this example for one to many, okay. So similarly for many to one, so for many inputs I'm getting one output, okay. So many to one type, so many to many, so many inputs many outputs. This can also happen in RNN. You can see this example here. So many to many, you can see this video example also. So like this, these are the different types of RNNs, okay. These are different examples, I can also say that, okay, examples of RNN, okay. So next we are going to see, yeah. So generally RNN is used for time series. So in this stock market I have mentioned, so how does the present stock value will be depending upon the past value of output and the present input also, right? So that is also comes under RNN category only. So you can see what is the time series. Time series is a series of data indexed in time order. Most commonly time series is sequence taken at successively equally paced points in time, okay. So you can see what is time series is, okay. So generally if I don't consider LSTM and GRU, what are the consequences I am facing? I will be facing vanishing gradient problem. If I used purely RNN, the simple RNN, if I use, I will face vanishing gradient problem. and exploding gradient problem. These two problems I'll be facing. So in order to overcome this, we have come with a special model called LSTM and GRU. Okay, so LSTM and GRU will overcome vanishing gradient and exploding gradient problem. Okay, so that is what it is describing, how the LSTM and what is the functioning of LSTM. Okay, functioning of LSTM take place. So that's, you can see. Okay, so now let me talk about this also. Yeah, you can see this. Okay, so how these all with the things we have discussed, and see this video. So this is my entire text. So to that text, how it is getting processed and how it is getting multiplied, processed here. Okay, it is converting into vectors, and those vectors are given as, taken as an input, and this is how it will get processed, all the vectors. So this is how it gets combined here. Okay, okay, it gives. Okay, so you can see all this, the GIFs type, and it is processed to the next hidden state memory. So tanh function is giving to next hidden state memory, how it is giving. So in this LSTM model, how it is happening internally, you can see it in GIF model. Yeah, on the whole, you can see the LSTM, GRU. So as I've discussed, what is the difference between them also. Here we'll have three types: forget gate, input gate, and output gate. So 3 gates will be having in LSTM, but as in GRU, forget gate and input gate are combined together, and we call it as that a special gate. Okay, and will be having one output gate. So in this we are having 2 gates. Here we are having 3 gates. So that is the main difference. Okay, you can see that is all those. Okay, the difference between them. You can see, watch this GIFs also. It is available in online also. You can see it, how that internal function will happen and how the output is given. Okay, in case of GRU, LSTM, and RNN. Okay, so this is how, this is what I can draw it here also. X of t and h of t. Okay, so this is the output, this is the input. Okay, so this is simple convolution neural network, or you can consider this also for simple neural network, but this is a special RNN, vanilla recurrent neural network. It looks like this, but simple RNN looks like this. So you can observe all these differences here. Okay, so that's it, I think. So thank you all. Thank you for giving this opportunity. So thank you one and all.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.